Okay, so this one kind of got cut off a little bit here. So I have to put my decimal after the first digit, so it's between 1 and 9 point blah blah blah. And then I have to figure out, what am I multiplying by 10, dividing by 10? I'm moving my decimal one jump, but notice this is a tiny number, so it's going to be a negative exponent. And the reason it's a negative exponent is because I want to take this and I want to divide it by 10. Like the 10 needs to be in the denominator, which is what negative exponents are. And so if you take this decimal and divide it by 10, it actually does equal that number there. If you look at the second one, that looks like someone tried to put it in scientific notation, but they kind of failed a little bit. And sorry, I had to go outside because people were talking there. And so if you look, they failed because this is not between 1 and 9 point whatever, okay? And so I am going to go ahead and fix it. And there's a couple ways you can fix it. One way is you can undo it and then redo it the right way. The other way is you can just kind of think about it. I'll start with the think about it way. I know this should have been 5.257. So I'm thinking I need to take one of these 10s from this guy and make this 10 times bigger. So then I know that's going to be 10 to the 6th. The other thing you could do is undo it. So when you multiply by 10 7 times, right, it's going to make that number bigger and you're going to move the decimal. So I'm going to just do that. So if it's here, 1 jump, 2 jumps, 3 jumps, 4 jumps, 5, 6, 7. So the answer, or the original problem, should have been that. And so now if I want to go back and put it in scientific notation, I'm going to put my decimal after the first digit, and I'm going to count my jumps. And so if you don't have a decimal, it's always at the end of the number, and I want it to go here. So that's 1, 2, 3, 4, 5, 6 jumps, and positive. So let me give you a couple ones to practice quick, and then we'll end up this video. So I'm going to pause it for a second to get up a clean sheet of paper, and we'll go from there. Okay, so the first two I want you to put into scientific notation, and the last two I want you to undo or put in standard form. So do both of these and pause the computer and then come back and check your answers. Okay, so I'm going to take my significant digits here, which is 34, and I'm always going to put my decimal after the first place so that this number's be between 1 and 9 point something times 10. I can't just change the number because I feel like it. I have to do something that's mathematically equal. So count your jumps. Your decimal's at the end of the numbers, so 1, 2, 3, 4 jumps. It's a positive exponent because this is a big number, and plus I want to multiply 3.4 by 10 4 times because mathematically these have to be equal. So if I take this decimal and multiply by 10 4 times, do I get this answer, this big number? Yeah, I do. Okay, next one. Again, these have to be equal. Take your significant digits and put a decimal after the first one. And then you're going to multiply by a power 10. Now count your jumps. 1, 2, 3, 4 jumps. And it's a negative 4 because this number is tinier than 1. And so negative exponents mean to reciprocate. So what it means is that 10 to the 4th power is really down here, which means I'm really taking 5.6 dividing by 10 4 times, which if you do that on a calculator, you better get that decimal. So when you have tiny numbers, less than 1, negative exponents. When you have bigger numbers, bigger than 1, you have positive exponent. All right, so let's undo the math. So this one has a negative exponent, which tells me that this thing I'm dividing by 10 twice, because negative exponents mean to reciprocate. It's kind of like that's in the denominator. So if I put it here, if I divide by 10 twice, I go 1 jump, 2 jumps. So 0.0308. And again, the negative exponent tells me that I should have something less than 1. I should have something tiny. And so when I move the decimal 2 jumps this way, obviously it makes it tiny. Because what I'm doing is I'm really dividing by 10 twice. So I could take this, divided by 10 on my calculator, should get some tiny. This should be a big number because do you see how you have a positive exponent? So I'm going to take my number and I'm going to multiply by 10 5 times. So 1 jump, 2 jumps, 3 jumps. Need to add a couple zeros. So 1 jump, 2 jumps, 3 jumps, 4 jumps, 5 jumps. So it makes sense that it's a big number. So what do I have? 400,000. For some reason that part of my screen doesn't want to work here. So let me write the answer up here. If I can get My screen's kind of freezing right now. I'm going to pause for a second and see if I can fix this issue, and then I'll come right back. Okay, so I was just going to rewrite this nice. So 400,000 and 900. And again, it's a positive exponent, so that indicates you should have a bigger number, something bigger than 1. All right, so just a quick review. Remember, negative exponents just mean to flip. So if you have something like 1/2 to the negative third, cube it like normal. So 1/2 times 1/2 times 1/2 is 1/8. But the negative, so this means to cube, the negative means to flip it, to reciprocate. So I'd take this answer and I would actually flip it over, 8 over 1. So the answer would just be 8. If you have something like, I don't know, x to the negative second, you just flip it because it means it down here. Now, I could do some tricky where I put the negative down here, and again, negative exponents mean to flip it, so that actually means it's going to flip to the top. So, and again, so in scientific notation, the negative exponent means that that 10's really in the denominator, which means you're really dividing. So 10 to the negative fourth really means that this is the reciprocal. This is really down here, so you are really dividing by 10 4 times, which is why that number should be tiny. All right, I think that's about it for chapter 4, and we can work more on this in class.